Hello all. Today we'll discuss the basics of statistical test, that is the frequency test and not the Bayesian tests. The statistical tests are essential for research studies and also for data science work, and to tell whether in our results, whether we have done some checks and we want to see in two samples if there is an actual difference that should matter to us. Today we will cover the concepts that one should know while selecting and setting up a statistical test. And in the next episodes we'll discuss more about interpreting the results of the test and focusing on one result, which is called the p-value. To explain the concepts, let us take deliberately a vague example of testing the differences in grain size. Let's say that we look at the sand on the beach, we look at the grain size, and we have another sample from grains on a river, and we look at the size. And then we get two such groups. We are not told about them, and we need to tell whether the grain size is statistically significant, different the size of the grain from the beach than from the river, the two locations. One, let's say, is San Francisco River, and then some sand beach. This is just an illustration, and we will cover specific statistical tests over the next items and episodes. So before selecting an appropriate statistical test, we need to identify the type of data that we are working at. Basically, there are two types of data, continuous and count data. Continuous data has variables that can take any value within a range, such as temperature, density, calcium concentration, and so forth. On the other hand, count data comprises counts of items in categories, such as the number of quartz grains in rock and the number of surviving species in an extinction. For continuous data, it's important to know the number of samples and the number of variables to select the appropriate test, because there are multiple tests. When we don't do a Bayesian analysis, then in this case we have multiple tests and we need to choose the statistical test. Like if you read about the t-test, the ANOVA test, we need to look at the properties of the input data that we have. Is it normally distributed? Do we have a single parameter, and so forth, and then choose the test. Is it going to be a t-test, an ANOVA test, and so forth. If we have a single variable, this is called a univariate data. Tests designed to compare two samples fall under the category of univariate data. For example, we can compare the pH between two lakes, calcium concentration in two samples of granite or shell length in two different species of corals. If we have more than two groups that we made measurements from, then we will need to choose a different test, because we have multiple groups, not only two. Only in two groups we can choose the t-test. If we want to compare more than one measured parameter at a time, it's called also multivariate data. It doesn't matter how many variables there are as long as there is more than one. There are different tests for comparing just two samples and more than two samples. So if we have two samples, there are certain kind of tests. If we have multiple samples, there are different kind of tests. For instance, we may want to compare both the pH and temperature. So it's two parameters, both the pH and the temperature in two lakes. Or we want to compare all the major chemical elements measures in 4 different samples of granite. Another crucial aspect to consider before selecting the statistical test is whether our data is normally distributed or not. If the data is normally distributed, which means it is symmetrical, it has a peak in the middle, and it is a unimodal with a single peak. Unimodal means a single peak near the center. Then we can say that the data is normally distributed. And then we can run something which is called a parametric test, which assumes that our data is normally distributed. However, if our data is not normally distributed, especially if our data is skewed, this means it's not symmetrical and we should use a non-parametric test. This type, the type of the statistical test that we are going to do, the first one, the t-test, relies on the null hypothesis, and also other tests are relying on null hypothesis. So let's describe a little bit what does it mean, the null hypothesis. So the null hypothesis is testing for significance testing. It involves attempting to reject a null hypothesis, often referred as H0. The first step is to formulate the null hypothesis. This null hypothesis assumes, in our case, where we compare the grain sizes, that there is no difference between the groups that we compare. For instance, in our example, the difference in grain size between the two locations, the null hypothesis would say in our case that there is no difference. So it's very easy to reject it. From the San Francisco River and the sand beach. So in our case, the null hypothesis will say that there is no difference. We can also state the alternative hypothesis, which is called H1, which could optionally say that there is a difference in between the data that we have from the two samples from the river to the beach, but we are not allowed to choose the H1 after we see the data, only before we see it. So to sum it up, we can have continuous data, we can have count data. Continuous can take any number in a range. Count data can take only specific integers. In the hypothesis, we are going to check the properties of our experiment, and if we are dealing with two groups normally distributed, then we can choose the t-test. If not, there are other tests. Then we state the null hypothesis. We check how many variables we have. If we have, again, one variable that we compare, like the mean or the deviation, then this is also okay for the t-test. Do we have two samples? Do we compare more than two samples? If we have two samples and we compare normally distributed and we have one parameter to compare, then this is okay for the t-test. If not, then not for the t-test. So this was a brief overview and summarization of null hypothesis, t-test, and how we should go about it.